Hello, ROOTCON. This is unixfreaxjp from Cyber Emergency Center of LAC, Tokyo, Japan. Thank you for having me. I'd like to make a presentation about the diving into Shellcode for the advanced analysis. About me, this is my support for doing it 30 more years until now. Not doing it so often during the COVID era right now. But it has many wisdom that I'd like to share with you, which is parallel to the security implementation. I'm just a security folks in a daily basis, doing malware incident since a senior analyst in the forensic group of the Cyber Emergency Center or the LAC Lizard. And I'm the analyst and the writer of the Malware Must Die blog too, doing a lot of community give back efforts and other activities in the first org as a IR activist of the team Lizard. So in the day work, I'm using a lot of stuff for analysis in the Cyber Emergency Center. We support incidents that coming every day. And after doing the day work, this is me and my team activities in analyzing bad stuff for the happening in the internet, and we try to do the share back cycle to raise Linux awareness recently, to keep the balance between achievement in analyzing, sharing, educational, and regeneration purpose. So this is in the simple words that current activities that can be seen in the web, explaining a lot of the status that we are doing now, and POC that what we shared. There can be few also in the if you Google the Malware Must Die, you can see there is a Wikipedia explaining a lot of activities in our blog. This presentation is having these chapters. Most important part after the introduction is advanced shellcode tricks on code injections. It has a memory map shellcode stub, cloning shellcode stub, using ASIL for the sophistication, and other tricks. And we are having the memory forensics how-tos and some comparisons. I'm sharing also the tools for the Linux shellcode analysis for the playlist stuff, but being utils and some cloud platform setup too, and some references and hint afterwards. What this talk is all about. I wrote this slide as a blue teamer based on the know-how that I have an experience in handling incidents on the cyber intrusion involving the shellcodes, and this presentation will be strictly based for the Linux platform. And it is as a share back to the knowledge to the fellow blue team folks dealing with the subject on the ROOTCON. So this is for the positive purpose. The talk is meant to be non-operational, non-attributive material, so it is written to be as conceptual as possible and contains the basic methods for this shellcode analysis in the shell platform. So I'm not using the GUI, using everything in the shell. So we will be dissecting and breaking the shellcodes on that kind of a platform. The material is based on what we are having in the Malware Must Die, not doing another material that either from the workplace or another groups or another TLP that cannot be shared. So most of the material are shared already in the internet. Linux, why shellcode is important too. In Linux, now it's the most influenced OS in the internet. Linux devices is everywhere, and it's becoming an important aspect of our life. And Linux is free, open source, and it is very good. So it has so many kind of the version. There are secure Linux, there are non-secure Linux. This is just a flip side of this operating system popularity. Linux executable scheme is so varied and supporting many executional scenarios. So if something bad happens, then the executable detection ratio is compared to the Windows probably is quite low at the moment. So this is why that we are focusing for the Linux awareness recently. Linux operated based devices is if taken over by adversaries, can be put in anywhere and can be implemented to some activities. Now, talking about this talk and its sequel, I've planned actually the roadmap for sharing the practical know-how on binary analysis on a series of talk from 2018, starting from the ROOTCON over there, firstly discussing about the packer, and then if you see the blue light, the color is a very important background to see about this presentation. Actually, in the 2019 in Hacklu, I'm explaining about the post-exploitation on the Linux fileless and infections, and then in this year ROOTCON I'm explaining about the basic shell coding for the Radar users. So after, if you have time to see this both two presentations, and then you can see it as a good background to view this one. So this year is the final part of Shellcode talks. Sequels in the ROOTCON is focusing to the advanced research and related to the previous talks that I described before in the blue colors. So there are also several other presentation that you would like to see, and I will explain it in another time. What we don't discuss in this slide is the basic of the shellcodes that explained here, because it's already explained in the ROOTCON 2020, and also not explaining about much of the injection scheme for the Linux, because it's already explained the Hacklu in last year. These are the place that you can gain the documentation from the previous presentation and talks, and video you can get it from the Malmersdai channels. You can start from the skill set that you're good at. Always having that motto is very important. So the will for you to try to gain something is much more important. Now going to the advanced shellcode tricks part. As a previous talks I explained, I'm going to explain it again and again about the code injection. Code injections is mostly is using ptrace that we know about that a lot, and to control the process flow and then to enumerate the address to inject after the states of the injection is gained. So state of the injection is gained can be any kind of a state that allowing you to push some code executable in the executable area, then the shellcode can be operated in there. The other part is a shared library executable to inject code in the memories. We are also having the code injection then can be pushed into the main function of the process, but it's not pretty. Not every process started from the main, so some has a preliminary execution also. So probably it's going to be worrisome for this kind of concept. And using of the ELF execution process, for example, ELF sections can be tempered, and ELF link library can be also tempered, and the tempering can causing for the executions of the either objects, binaries, or shellcodes too, and the combination of all of those techniques can be used. Ptrace is useful to gain control for the code injection state. Shellcode is mostly being used a lot to inject instead of the ELF binary and SO libraries, because of shellcode is very small. The most common usual techniques to shellcode injection is like this. Using the ptrace pick text mostly to back up the predefined memory address, get register to back up the ptrace use register, and then the poke test. We have the set rex continue to make a code execution. But I'm going to focus here for the poke text that they're having the overwriting mmap2. So the topic right now is a memory map shellcode stuff for injection. This is quite the interesting part actually. In one incident, we spotted this shellcode stored in the memory in the 64-bit servers. What this code is all about. So this code is like this. You can ignore the last two lines there. It is spotted in the running process as a one-stop of the another shellcode as a preliminary injections before the other shellcode is performed. So if you can see, during the seeking in the memory part, memory area over there, this is the address the upper than the VDSO in the stacks, and then all we have to do is understanding which the shellcodes are, and then as per explained the basic shellcode, we put it all of the data into a simple wrapper like this. And if you can code it well with CDOH, or sometimes with string H if you want to see the length too, then compile it with the no stack protector and then permit it in the executable for the stack. The point for the regeneration is to dynamically analyze the shellcode in any kind of the debugger. I'm using Radar for this purpose. So you can run it and then you can see how the register is working, and then you can figure out how it works like this. The first line is to zero out the EBX, and then the ECX will hold the memory size into 1,000 bytes, and then the ECX holds another argument for the memory page permission to 7, means supporting for the read, write, and executable, and then another argument for the 22 hex means the memory map type is set into private and anonymous. So basically, this is how it works. Shellcode is invoking the syscall mmap2 to allocate the memory space with 1,000 byte size, then allocate the memory area flag as a private and anonymous, meaning an independent space process has been created that can be used to execute any malicious code and store any data. And then the permission is tempered to be read, write, and execute, and this is a sign of the code execution over there. So the most important part is mmap is returning for the pointer of the execution that can be performed for another shellcode. Then during the OSINT, we found that this is actually the tools that is using this map shellcode stub for injections, and this tool is actually shared in the GitHub. And seeking further in the internet, I found that Pancake is coding similar stuff that actually is a good improvement for this shellcode stub mmap in the C. So this is a kind of interesting one. So as the stager or preparation for actual payload shellcode to be executable, it's interesting. The next case is shellcode clone stub. Shellcode clone stub is used as a stager or loader to execute the real shellcode. Normally, it will clone stub shellcode will return to its parent after execution, but in several incidents, it was detected that it is killing the parent process. The purpose for the clone stub is to be a stealth code injection, leaving the victim blind on how the payload shellcode has been injected. The rest of the payload shellcode can be anything from the reverse shell blinds and anything at all. That is for the payload stuff. The design is like this. The clone stub is preparing for the for the cloning of the actual process, then executing the another shellcode. If you break down the code, we can see that it is forking first, and then check if forking is successfully. If success, it will jump to the payload shellcode. If not, then it will kill with a seek user 2. Or it can be anything, for the signal. So kill signal can be used, and you can also return to the parent process. So any kind of modification is very applicable for this. If we rewrite it to the, for example, .SL language in the assembly, basically it will look like this. And then if we generate it, so first I was so lucky because I found the binary that actually injecting this shellcode from the code forensic. So first the attacker is executing any kind of the binary, then grab the PID and injecting the binary called injecting itself, and then with argument of that PID, it will execute it with forking, and then after that in the fork PID it will making a callback for the 4444, which is actually the payload from the bind cell. So the case of this clone stub is you see the strings over there. The strings that in the opcodes can be used in the router for the actually searching which part in the memory is having this injection, then that information also can be used to do the ocean investigation. Then we see that this is actually the source of the injection source, which is a GitHub open source red teaming material too. Another one is obfuscating assembly shellcode analysis with ACL on Rotary too. Well, we have this kind of the shellcode. It is running, and then it has some bogus of you see the string of the sh bin over there, and then we have to be precise. So we start analyzing, regeneration it, and then compile it, and then seeing the binary, and let's do the static analysis for this one. In this part, I'd like to make some demonstrations about how to use the Rotary tool for the real analyzing of the shellcodes. So probably it will be good for the reference for you guys. So let's put the shellcode into the wrapper like this, and then it's a very simple one, commonly being used. And then I'm not counting any length here. And then I try to making a copy paste of the compilation ways that I'm usually done. So it is done. Then checking about the binary, is it there, and run the Rotary to load it. In the Rotary, so I analyze the function, and then I extract the information over there, but there is no main being spotted anywhere, so you don't know about that. But based on the experience, it's probably in the push dword EBX minus OXC, but we don't know about where the EDX is. So we use the ACL for this. ACL can be used, first you have to see the base address is in the entry 0, initiate it, and then perform for the stepping, and then now you can see the EIP is changing to the still in the entry 0, and now we are seeking for the EBX minus OXC is all about. So we are just like doing the any stepping for the until some address, we use the AESU for that address, and then the EBX must be being executed beforehand. So we go to the EBX and let's reduct it with the OXC, and then we found that the main address is written over there as a dword. So this is one powerful thing of the ACL. We go to the main address then that we have to figure out with the ACL, and then we try to figure out where is the shellcode is. So based off our own compilation is using the very readable binary there, so it's not stripped at all. So there is a value EDX that actually keeping the value of the as you can see the payload of the shellcode here. So we go to the first address, we try the ACL again, and initiate it, and then starting from this main function first, and we go to that address which is before the EDX is done. So we can check the EDX address after the AESU is executed, and then the payload has to be there in the address of the 640. So this is actually the address of the payload is located, but that is actually the code, but we have some strings over there which is are really disturbing about the reading of the opcode. So it's let's cleaning this up with magic commands that Pancake told me before, and then this is actually we analyze it again, and then we're doing the PDF, and we can see it clearly about how the opcodes will be. So right now we see the shellcode is going to be like this, and all I have to do is making a comment on each part that being informed here. But there are some parts that probably need to be corrected, like this assembly is very wrong. So it's supposed to be OXFFO. I think there is a mismatch with some kind of Indian operations. But anyway, so FFO is like a 65520 for the decimal values, and then its EAX is pushing for the 17 167 is actually having the ASCII number of decimal numbers of the 359 is well, you can see it in the, this is actually one of the values of the syscall that you can check it later with a unixfreaxjp. The other value is about IFINet, and then we found the sock stream is there. So it's definitely the very known syscall of the socket here. So socket is executed after the syscall being invoked with the interrupt 80 there. So this is the socket. We have the domain, we have the type, we have the protocol. So the upper information are the struct that is used by the socket to define the domains of the connections. Then another, with a similar ways, we can dissect also the other part, like there is a bind syscall being used. EAX address is containing which syscall is actually being used. In this case is bind. You can see it again in the reference in your Linux platform in the unixfreaxjp. And then this one is 16C, which is having another flex, and this is actually the accept 4. Accept 4 is having after you are binding to something, and you listen first, and then you can accept any command that being sent over there. Then you can keep it in the some registered one of them, and then there is a connection. There is a file descriptor for after the connection is established that being used again and again afterwards. And then you can see the interesting strings of the bin sh that is being pushed to the stack there. So beforehand there is a duplication. So if we reference for the C prototype, we see that the dup2 call is iterating 3 times in order to duplicate our accepted connections in the std in, std out, and std error. The file descriptor that can make the connection interactive for the user. So it is supposed to be looping for the 3 times for supporting those. And then the last syscall is execve, which is having an argument for the bin sh. So it is for executable. So this is actually what dissecting this shellcode is all about. We can see it is a typical bind shell. It's listened to the address of the FFF0, which is we can ask the writer for this, and then it means that 65520. So let's demonstrate it if it is correct or not. So if it is compiled in the right way, so it's supposed to be running, it is running now. So from the another machine connected to the virtual machine being used, gaining the connections, and then as you can see, the uname is being pasted over there. If we break in here, the connection will be lost. Actually, this environment is FreeBSD. So that's for the demonstration. So we go to the more tricks reference. There's a very good one that I'd like to introduce to you. There's a pure in-memory code injection with a Linux userland, memory injection with a clear sample, and a Python regeneration script that can be used. And another one is a Linux-based interprocess code injection without using the ptrace, but manually doing the calculation for the proc PID maps and mem, and using the LD preload for the injections. Another advanced code tricks is Linux inject. It's creating the state of the injections is set by the ptrace functions, but the injection is being done with a libc DL open mode, which is a part of the injected set library that you can see in the screenshot over there. This is the injected set library in there. And then after that, you can see the ptrace write is used for the invoking the shellcode, and then the continue for the executions, and it has the OXCC for the interrupt. Then the other one is Injector without libc, bypassing LSR, supporting multiple inject objects with this mandible Linux elf injector. So you can see all of these trees referenced in the previous talk in the HackClue, so you can see much more detail over there, but these are very sophisticated for you to understand, but the many kind of technique can be used to inject the shellcode into the memories with process injections. Now, we are talking about the shellcode in memory analysis, hot forensics versus the regenerate or reproductions. Popular questions: why people don't tend to do the hot forensics in memory for the Linux? Can regeneration process result be trusted on the fileless cases? Or what is the merit or demerit of hot forensic versus the regeneration? So all of the question will be answered in this table. So first, hot forensic versus regeneration, right? For the doable or not easy to be granted for the hot forensics because of many people are concerned about the sharing the environments, but it's actually very good for the cloud incidents because we can also run a similar cloud easily. For the risk, can ruin the artifact, of course, if you are doing something wrong. So hot forensic can really messing the artifact a lot. And then in regeneration, it's more safely in the experimenting stuff, so you don't have to get those risks that we will have in the hot forensic miss. For code artifact, if it is executed, it has to be there for the hot forensics. It's a matter of that we can see it or we didn't see it. That's it. So for the regeneration itself, maybe it's not working as per expected because we are regenerating something. If we are regenerating something we don't know, then probably we will miss on something too. The cost. For the cost of the hot forensics, it has a school delicate arrangement. It's very costly. Against the regeneration, we'll need the environment development skill and cost for that. Verdict possibility for the evidence POC quality on hot forensic is high. Need more effort to develop to develop closest environment as closest to the real one to gain the POC quality. Cold forensic support for the hot forensic is every artifact can be used for the search, and in the regeneration, the testing artifact can be used as the clue for more artifact carving or on the cold forensics too. Well, this is actually summarizing about the forensics hot to cold, but let's see how is availability of the hot forensic and cold forensic in Radar 2. For the seeking, it has hot forensics that can be used / command for the searching anything, but it is very limiting for the piping and script support due to we are dealing with a live forensic on live memory. Another one is for cold forensics is we can have more piping and script support. Sizing, we are dealing with a memory block. The other one for the cold forensics we are dealing with the HT image block. Its size is very different. For bin diffing, both can be used with a magic seeking command with a /m or /pm, and has the risk for debugging and has time consuming because the size is very big for the cold forensics. Right, so the next is about the binary artifact analysis scan. Supports hot forensic supports memory analysis with carving artifacts support to the Frida analysis and another kind of plugin, but cold forensics can be having more resource, so it can use signature, it can use Yara, for example. And for the standalone portable support, hot forensics is probably depends about what you can mount, and then for the cold forensics testing, artifacts can be used for the clue, and others can mount for anything that you can mount. The other tools for the shellcode analysis, binary tools, I'm going to discuss about the 4 tools here, but Radar 2, GDB, Jira, and IDA. But for the Jira, it's already included for the Radar A, so I'm not making it specific here. It's because I don't like really using Java very much. Radar 2 is, as you know, open source, powerful. It supported the static dynamic error tools and etc. GDB is open source too, and basic dynamic analysis tools for the debugging Linux executables is a very wonderful beast. And IDA is a very commercial tool for reverse engineering professionals, supporting the useful analysis plugin, which is based on orientation from the Windows environment. So we have a good work from the development tools, development people to make a comparison between the R2GGB and IDA commands in the good tables like this. You can see in this URL. So there's IDA Pro, RADAR 2, rather in the visual mode. Visual mode is more like you're using the keystroke for the controlling the GUI of the cell RADAR and so on. Another tools that very important for you is a GNU BinUtils. There are 12 of them. They are very important. Like we are having AS and LD. I'm using NM a lot for to make a list of the object file symbols, especially with stuff that cannot be entered with the RADAR. There's object dump, which is very powerful. Strings, we can use it a lot. The readelf and strip is pretty much being used for any kind of operations. This 12 tools is very much important for the BinUtils, and there are tools, another tools also that being included in the BinTools that can be useful for you guys. So I recommend that you are always having the GNU BinUtils, but there are environments that not supporting GNU, for example, like OS X, will popping you some alerts. For the cross-compilation platform, there are tools in my minimum recommending for the cross-compilation compilation tools setup. I like to use a build root a lot, and then it needs to have the libncursedev development, and then for the checking, I'm using the QEMU user static or QEMU system something to run environment as a VM or as a executable emulations. And then another cross platform is a UClibc cross compiler, and for assembly I'm using an ASM. So for the conclusion that we are having today, why we need to know a shellcode this much. The shellcode attacks on Linux and other OS also is getting more advanced every day, so we have to follow them. And how to follow them can be seen in the next page checklist. And the most important thing that I want to explain to you is what skill set they really need to doing the shellcode research. You can start from anything that you're good at, and if you can code, you can code. If you can do the regeneration, you can do it in that, and you check the behavior and so on. The shellcode checklist is very important to make a clear definition about the shellcode is all about. To gain shell for the command or file executions, as loader, as downloader, as another kind of interesting stages that is possible is using sockets a lot for the operations, and for the purpose to be a fileless and leaving no trace artifacts. So we can collect the shellcodes with the information that written over there, post-exploitation tools, self-generations, adversaries, cyber threat intelligence, exploit development sites, vulnerability POC, and trolling the red team or two. So in a good ways. Well, tips number one is for the shellcode handling in forensic perspective can be done. For the digital forensic faults is important to understand clearly how is it executed and compromised. Shellcode is not coming by itself, so it's using any kind of help to get to any execution state in the system. And then are we prepared for this type of intrusion? Is oftenly a question that has to be asked to yourself. Whether while you are analyzing the new shellcodes, you can rely on another environments logging like a network server, proxy firewalls, and etc. If a suspicious threat resource can be gathered through the artifacts or carving that you seek, then you can find it in the OSINT that there is a source of the threat that you can get. Try to reproduce it yourself and try to carve again the artifacts that so that you can find stuff that maybe you miss or unseen, or another possibility that might be helping for your investigations. Lastly, is to make your own signatures and make your own playbook is recommendable for some specific threat, so you can have a very good reference in order if the incident will come again later on in your work or helping others who's having the similar threat. The next is my Blue Teamer playbook share on the Shellcode. First is we have to be resourceful enough when dealing with a Unix-based system, and do not be afraid to analyze the live memory. Then you have to use the independent and trusted and a good binary analysis tool that you really fit with your environment and with your typical ways to analyze any kind of the artifacts, binaries, and the carving. And in my case, Radar 2 is a very good tools that to do for me with any kind of the binary codes. Third, investigate as per shown in the previous examples, meaning that you have to be very systematic, use some methods, use your previous playbook and adjust it with your own policy, with your project, with your workplace, with your environment, with the culture and the requirements needed to perform the investigation or analysis or research. The three things that practically that the Blue Teamer are good at, and that can bring a very good interruption for the adversaries are Blue Teamers can basically break the codes better. We can combine analysis between the other fellow Blue Teamers, if we know how to regenerate and share ways to do the ocean research, and then making much of the info security to be shared and in the responsible ways, then this can make the game more fair for any of us in dealing with the strong adversaries that lurking us by days or by the targeted attack. The documents is a very important one, and if you make a documents good, if you doing the good playbooks, and if you do the much good libraries database for your signatures, the more and more your report and knowledge can be useful for not only verticals but the horizontal purpose, and not only for today but that can be used as a reference for the future and to improve the current handling, the current reverse engineering, or the current analysis methods. We have to support the open source community so we can help any kind of the things that we are able to help them, like if we can help them to test, just do the test. If we can do the much advising, then we can do much advising for any kind of the stuff. We can help in the translating stuff, we can help them with the coding, we can help them with the reporting the bugs and so on. And this will build a good security community, and many people will be being in the same needs and in the same purpose, gather together to improve the tools and the framework better. Then these are the reference that is very good for you for analyzing the Shellcode in the future. We have Venom there, we have Parasite, Linux Injector are very good. Mandible is using this link for the GitHub. There are also Slay, there is a Injector, there is a Vigil, Procjack, etc. That all of these tools over here is having invoking for the Shellcodes that can be used for you to see how they are building the automation Shellcodes, which kind of the template they are using, what kind of the logic, what kind of the data being injected, what kind of the format, and what kind of the signature that actually can be used for scanning them if you're finding it in the artifacts during the investigations. Well, by this, I'd like to make a last salutation and thank you for the ROOTCON crews for having me doing this talk. Many talks many thanks to a lot of people who support my health recovery condition during this pandemic era. So this know-how can be possible to share. And please see our talks material from 2018 if you are interested to some binary analyzing. Probably will help you to open more vectors in the making approach in your ways to analyze something, and maybe you'll like them too. So again, thank you very much, ROOTCON. Thank you for you guys for listening, and I'm ready for now for receiving any question from you. Please change to the moderator for the questions and answer parts.